Good afternoon, everyone. Thank you very much for joining this webinar. This is the second part of an introduction to QuantumGIS. It's very well-known open source GIS software. Let's start with the presentation. So like I was telling, we did the work last week with vector file, and I think it's clear. We find out that there are three types of vector files: point vector, line vector, and polygon vector. And today we are going to work with raster file, and the raster file, it's a different way to representation. It's a picture actually where you have many pixels. A typical raster file is Google Earth imagery, but as well digital terrain model can be a raster file. And the raster file is characterized by the resolution. It means the centimeter per pixel. In QuantumGIS, or as a site planner, the most important raster files that we are working with are the digital elevation model, digital terrain model. We have seen that in previous workshop, and then background maps like Google Earth, Bing, or OpenStreetMap. And of course, satellite imagery. And the well-known is Google Earth, is a satellite imagery, but we have many other satellite imagery, like Sentinel and the Landsat. We are going to see today the Landsat. In future, we are going to see the Sentinel imagery. Okay, let's start with the first example with the digital terrain model. There are two ways to find a digital terrain model and to download it into your computer. The easiest one is the way that we have already seen through Global Mapper. And the second one, a little bit more complicated, it is through Earth Explorer. And I will show you later why it's very important to know this Earth Explorer. But let's first start with Global Mapper way. But of course, those rasters are not of very good quality. And if you need a really good raster, you have to produce it yourself. For example, with the total station or with the drone, but we have spoken already about that. Let's go through Global Mapper and how to find the digital terrain model through Global Mapper. Today, we are going to work on an area in Syria, east of Aleppo, where we have four well-known IDP sites: Admet, Ka, and Sarmada, and Kafr Arek. Those sites are famous because frequently they are flooded. As far as I know, they are managed by Watam. And thank you to Sahid, who gives me this shapefile for this exercise. So what you have to do first, you open Global Mapper and you identify the sites that you are interested to with a vector file. You can see in this slide, we have in red here, the sites. Very first thing that you have to do once you have opened the vector file, you have to download any background imagery just to be sure that the sites are properly georeferenced. This is also because you have to be sure that you have the right projection. If you don't have the right projection, you will have trouble, and I will show you what happens if you mismatch with the projection. Once you have displayed your sites of interest, like this one, just click on Connect to Online Data, like you have done already. You will have this mask. Under Popular Sources, you will have the SRTM Worldwide Elevation Data. Just click on Connect, and the digital elevation model is going to be downloaded to your computer. But it is going to be downloaded in a temporary file, not really physically on your hard disk. So I think it's not really important to speak about the digital terrain model. Just I want to remind you that this digital terrain model is not very precise. It has a resolution of about 25 meters. So it's fine to have an idea about the ground, but it's not good enough if you need to make really construction work, especially drainage work. Okay, once you have downloaded on your global mapper the digital terrain model SRTM, you will have, for example, such a display, such a layout. You can, of course, drag your digital terrain model layer up, and then you will see appearing your 4 sites of interest. This is good so far, but like I've told you, this model is not saved on your hard disk. In order to save it on your hard disk, you have to uncheck all the layer that you are not interested on and keep checked only the digital terrain model, like you can see on the screen. Once this is done, just go on File, Export, Export Elevation Grid Format, and then you will get this mask. In this mask, you have to select Digital Elevation Model. Once this is done, you have another mask. This mask will ask you to put a name on the layer that you are going to download. For example, Digital Elevation Model IDP site. Then you can choose the vertical units. Usually I work in meters, but it can be feet, it can be whatever you prefer. And then you have the resolution, the sample spacing. If you increase the resolution, you put a small number on that, the file will be big, but the quality of the precision of your digital terrain model will not improve. What it will improve is just it will look nicer. But you know that the spacing of the digital terrain model is around 25 meters. So if you put a number between 10 and 20 is fine. If you put a big number, then you will lose of information. So put a number 20 or 10 or 15, but not, if you put a too small number, the file will be very big, also depending on the size of the area of interest. Important as well is that you check this generate projection. This also in order to keep the original projection that you are working on, UTM 37 North. If you don't put the projection, you might have problem later when you upload the digital elevation model in your qGis. Of course, global mapper need to be set up with the right projection in advance. Okay, then it will ask you where do you want to save your digital terrain model, and the process of downloading will start. Depending on the size, it will take a very long time to a very short time. Then 2 files are going to be generated. The digital elevation model in themselves, which is 131 megabyte, and the projection files. The 2 files belongs together. Once this is saved somewhere on your hard drive, you just have to open it in qGis. And in order to do that, just click on this icon or go, yes, click on this icon. Select here raster and not vector, like for vector, just select raster. Choose the location where you have previously saved the digital terrain model and click on add. You will see the digital elevation model will appear. By default, it will be a black and white picture. You will see here the highest and the lowest elevation. And again, you can drag the other files of interest up so that they are going to be visible. Again, download through this background map, just to be sure that your digital elevation model is properly placed. This is one way, and in my opinion, the easiest way to download on your hard drive the digital elevation model. But there is another way. In case that you don't have global mapper, there is a web page, Earth Explorer SGGS Gov, and this web page is very important because it has a lot of information, really a lot of information, including the digital elevation model. And this is the web page where we are working now. First, with the first example, we download the same digital terrain model through this web page. You go on the browser, you type Earth Explorer usgs.gov, and then you will have to register. It's free, so don't worry, register. Once you have registered, you log in and your name is going to be appearing here on the top right. The very first step that you have to do is to navigate to the location of interest. There are two ways to navigate to the location of interest. You can just move this map with your mouse and the wheel, zoom in and zoom out. When you are at the right location, just click Use Map. Or there is another way, which I prefer. You can use a shapefile. Of course, the shapefile has to be produced in advance, either with qGis or Global Mapper. And then just select the shapefile and click OK. The thing is that the shapefile must be is composed by 5 files, like we have seen last day. So you have to zip the 5 files together, and then you have to select the zip file. Once it is done, just click OK, and your area of interest will be displayed automatically. And the coordinates of the corners as well are going to be automatically displayed. That's it. Next step would be to tell to the web page what type of data are you looking for. You will see there are plenty of data, plenty of satellites. You even have drone data, really a lot of data. But for this first example, we are going to concentrate to the digital elevation model. So you select first data set here. Then you get to digital elevation. You see you have many types of digital elevation. To be honest, I don't know exactly what they are for, but just select SRTM and SRTM 1 arc second and click result. Once this is done, you will get one file. And this is the result. Here, if you click on that, it will show the footprint. It means it will show you the full area that this file will cover. And if you click here, you can download the file to your hard drive. By default, the file is going to be downloaded on your download directory. You will get this mask. You have to click GeoTIFF, and you see it's not that big. So the downloading process is going to be rather quick if you have a good internet connection. This is the footprint that I was speaking about. It's actually too big in the normal cases for our interest, so that in case you want to use it in qGis, you can crop it as well. And to crop it, to clip it, just go on raster, extraction, and clip raster by mask layer. It's an easy process, but to be honest, the process with the global mapper, it is much forward, much easier, much quicker. But it's important to show that because later we are going to be back on this web page. Now, like you can see, the digital elevation model that we have downloaded doesn't look very well. Okay, I forgot to tell you that please check as well the projection of your digital elevation model. It must be the right projection. Otherwise, you will not recognize that you are doing terrain analysis on the wrong place. And this will, of course, lead you to take wrong decision when you are opening a new site. So projection for Syria must be UTM 37 North. If not, you can change the projection afterward. Go on raster, projection, and warp projection or reprojection. Doing like that, you get this mask. Input layer is your digital elevation model with the wrong projection. Target projection, the right projection, and run. Of course, you have to save it somewhere on this place. You save it somewhere with the right projection. Fine. Done that, we want to change the style of our raster. And in qGis, there are plenty of possibility to do it nice, to look it, that it looks nice. What you do, you click on the styling panel or F7, and you will get this mask. By default, the digital elevation model will have a single band gray, that's what we have seen before, but it is not very nice looking. So let's go to single band pseudo color. And then here you can choose a big number of palettes. You can have from black to blue to many types of color. If you go to all color ramps, you can choose all the color, but even that you can create your own ramps of color, depending on the elevation. I like to have blue on the bottom and red on the top. So what I do, I go to red and blue, this palette here. I click on that and then have that. You see single band color. The rest, there's minimal elevation. This is all automatically by default, depending on your digital elevation model. And here you have 5 classes by default. But here I have red on the bottom and blue on the top. So if I click here, I can invert the color ramp so that I have blue on the bottom and red on the top. And as well, I want to have equal interval. So I click on equal interval. I will want to have 8 classes, for example. Then you put the interval that you like. If I like to have it every 100 meter, click in apply, you will have that. So what I want to show you is that you can display your digital terrain model as you like. It's really free, just have to spend some time to understand this possibility you have. Once you have your digital elevation model on qGis, you can start exactly like you did for Global Mapper with the terrain analysis. Most of the commands for the terrain analysis are under command in raster, or there is a panel called Processing Toolbox and Terrain Analysis. You can do slope analysis, hillside analysis, contour line analysis, watershed analysis, plenty of analysis. You can as well display your digital terrain model in 3D, like you do for Global Mapper. But in my opinion, this is a very personal opinion, Global Mapper, it is much more better performing. The reason behind is that you have more opportunity to shape your result. You can give more detailed information that are somehow matching more the reality. And additionally, it is much more user-friendly. But like I was telling you, not everyone has access to Global Mapper. That's why qGis could be a very good alternative to Global Mapper.